Hello, welcome to today's episode on Rawkode Academy. I wonder how many times I'm going to mess that up over the next week, but welcome. Today we are continuing our journey with Rust. We're going to dive into one of Rust's more unique features, but also one of its most understood, especially by me, and problem domains when it comes to learning Rust. So before we get started, a little bit of housekeeping. First and foremost, if you want to chat, drop as much comments as you want into YouTube's comments. We will do our best to get them on the screen. If you have any questions, we'll do our best to answer them. In general, just let us know how you're getting on and how we can help. If you're not watching live, the best place to ask questions or join a conversation is on the Discord. So that is available at rawkode.chat. You can come in there, join anytime, and ask any questions. Also, since the rebrand to the Rawkode Academy, we now have membership options available. You can join for a very tiny fee, and it just gets my eternal gratitude and support. So thank you to the members that have done that already. I appreciate your support. And of course, if you don't want to do that, that's fine, but please subscribe and please click the thumbs up button on the video. This will help other people find this content. And today's episode is really important because this stuff is hard. And because it's hard, I can't do this alone. I am joined by my friend Anna. Hey Anna, how are you?
Hi, I'm great. How are you?
I'm very well. All the better for us now being here covering this wonderful topic today. Would you please do us the honor of just telling us who you are and please share anything that you wish to with us and the audience?
Gosh, I'm about a 7-year Rust user by now.
7?
So I've spent a lot of years with the borrow checker and lifetimes. Still get stumped sometime. Thankfully, the error messages are good. I live over in Victoria on the ʷəŋən territory in Canada. This is my dog over here. For my work, I basically create a toolkit that lets you write Postgres extensions in Rust.
Awesome.
Yeah.
So you've spent a lifetime learning lifetimes. It took me so long to hold that in, but I'm glad I got it out.
I like it.
So before, I can always just throw the terminal up already, but why don't we chat for just a little bit? Like Rust, I don't think any other language has this concept of a borrow checker and lifetime. Is that right, or am I being a little naive there?
I think if you look at tooling that exists in the C++ and C space around static analysis, a lot of them do very similar things to what the Rust borrow checker and lifetime system give you. Fundamentally, they don't come with like Clang though.
Okay. And you're gonna make this easy for me, right? Like,
I'm gonna try. I'm not gonna like stump you.
I mean, I don't often get worried, except when I actually have to show my own coding ability, in which case I do get a little bit of the fear. But I mean, I've got to say, I've been writing Rust now for, I don't know, I think nearly 2 years, and I just seem to like avoid these things as much as possible and stick to writing really simple Rust code whenever possible, and that's worked really well for me. I think, in fact, I'd probably bug you a lot now when I come across stuff and I'm like, I don't understand it. But I mean, this stuff is not exactly I don't know, it's not hard, but it's not easy either. Like, I think if you just, I'm hoping that if we just spend a little bit of time and cover the primitives, so this is just going to click for me. That's what I'm hoping. That's what I'm trying to say.
I'm hoping so too. You know,
Right.
I most of the Rust code I write is extremely simple, and like I call clone everywhere, and it, I feel shame sometimes, but honestly, it's not a big deal. Like the cool thing about the borrow checker and lifetime systems is they allow you to do a lot of the deep, subtle refinements that allow you to process terabytes of code very quickly.
I've got to be honest, I reach for .clone an awful lot in my Rust code because I know it's just going to remove the error. And again, I'm avoiding having to learn that next thing that I need to learn. Either that, or if that's a lie. What I do first is I add an ampersand, and if that doesn't work, I do a clone. And that is my entire knowledge of like the borrow checker, really. I'm just like, oh, is that going to work? No, it's not going to work. And then it'll say, oh, it doesn't implement copy. I'm like, why not? And then I just try and clone. No, the clone doesn't work when it doesn't implement copy. and the ampersand doesn't work when it doesn't implement something else. Anyway, I am ruining my description of this. We're going to rely on your knowledge for today. So
When I'm writing my Rust code, first I make it work, which usually means throwing clone everywhere, and then I make it right, and then I worry about making it fast.
well, I never have to ship code to production because I'm a developer advocate, so I don't care about the fast. But I would definitely like to learn today how to make my code at least a little bit more right.
Yeah.
Okay, let's get my screen up. So we're going to start, and I think we'll probably drift away from these relatively quickly and start typing our own terrible Rust code. But the Rustlings example are a really good way for anyone watching that wants to learn a little bit about Rust. It has a whole bunch of exercises that introduce you to some of the common themes. Enums, functions, generics, modules, macros, etc. We're going to spend, well, I don't know how long, but a little bit of time on Move Semantics, and then we'll dive into the other components of Rust and ownership. At least,
This is
unless
exciting. I've
Anna
never
wants to
looked
correct
at
me.
wrestling.
You've never looked at Rustling? It's because you've
No.
already got all the knowledge. So yeah, let's take a look at the first example. Like I said, I think we will veer off and type our own .main.rs or whatever and just maybe run some code that way. But we'll start with this. We'll see I actually don't know what it's going to try and teach us. I'm hoping it's the right stuff, and we'll just take it from there. Now, if I remember correctly, and a smarter person would have checked before going live, is that we can remove the I am not done comment and then run something on the command line, and it'll tell us if it's correct. Seems to be the vibe of Rustlings. And we've got our first bit of code here. So what is this doing?
So here we're constructing a new vector, right? So one of the first things you probably encounter in Rust is you want to make an array of stuff or a list of stuff, which usually, in Python you do with your square brackets. In Rust we have those. They're called slices. They are unowned, which means you don't actually get to play with the array. It's just usually they're pointers to slices. So vectors are actually owned arrays or lists or whatever you want to call them. So in here, we're actually creating a heap allocated owned pointer to this memory buffer of what are we filling it with? We're filling it with I32s.
Yes. Okay. Let's. Oh, I don't have Rustlings. Please stand by. I mean, the Rust compiler doesn't take very long, so this will be really fast.
Really, I think you're the first person I've ever heard not complain about the compile time of Rust.
I was complaining about the compiling time. I think I was just too subtle with my sarcastic undertones there. Where's... Oh, am I going to have to look at the README? I thought it was just cargo install. I can't believe I removed it from last time. Oh, there we go. This will do. Curl bash. Nothing ever happened badly from curl bash. Don't judge me too much, Anna, please.
It's fine. A curl bash wouldn't work on my machine at all, so I'm kind of jealous.
Oh yeah, you've got to have derivations and safety and protections and all of this other stuff, right?
Yeah, I don't have a bin bash.
Does Nexos not ship with fake ones that link to something else, if I recall correctly, to try and make it sometimes work?
Well, idiomatically, your bash script should be calling user bin env.
Yeah,
bash.
user bin env, yeah.
So that's what NixOS supports.
That makes sense.
Yeah.
All right. Well, it's actually going a lot quicker than I expected, which is good. It's only got a few more packages left to build, and then I'm assuming, and I should again know, we'll run Rustlings Move Semantics 1, and it should tell us that it's failing. I don't think we need the hint. We'll just tell it to try and run it. And normally what it does, it'll give us an error message, and then that'll tell us what it actually wants us to do. Now looking at it, I'm assuming the challenge here is going to be this print line vec will be taking ownership or something, and then the push is going to fail. I think that's what it's going to yell at me for. Do you think I'm right, or am I wrong already?
I don't know. Let's
So
see.
I'm looking at it and I'm like, okay, we've got the fill vec, we return the vector.
So what's the exercise here? Because I feel like this might compile.
Well, let's just run it and see. So we don't need to. We can run rustlings. Move Semantics 1. Oh, what's this thing?
It was in the top of the code file. It was.
Oh,
in
that
the
was for
top
the
of
hint, and I don't think we need the hint yet. Oh yeah,
Oh,
run
okay.
my exercise. Okay, so rustlings run.
Oh, you type like me.
What do you mean?
You also mistype all the time.
Oh yeah, that's just the rule of being on a live stream.
Oh, this
Yeah,
is
Russell,
fair.
I'm not running
This is fair,
watch
yeah.
because this is the fresh clone of the rustlings. I'm not going to walk through all of them to get to this stage. So we'll just
Okay,
use
so
run. But we have our error message.
yeah, so you might notice if you haven't looked at Rust before, which you have, though, that the error messages are quite verbose and good. It does explain what's happening. So we've got this vec1 that we've declared with a let binding, and it's not mutable. And that's because mutability is opt-in in Rust, which is a very nice thing.
Okay. So our first error message is just telling us that we need to make this mutable. Done. Is that it?
Let's see.
And that was easy. So you were almost right that it would compile if we just missed immutability. And I'm over here trying to overthink the ownership of this vector going into the print function or the print macro.
So why do you think we didn't have an ownership problem here? It's because this fill vec1 takes a vector and also returns it, right?
Which line, sorry?
So if you look at line 18, the fill vec function, it takes in an immutable vector and it returns a vector, right? But you see at line 19, we actually can opt into mutability there.
Oh yeah, because okay, so we're getting a vector back here that isn't marked as mutable, but we can actually tell it to become mutable. So we're like, what's happening here?
Yeah, so two different things are happening, right? So to push onto a vector, you need to mutate it. So when we made vec0 on line 7, and we passed that into the function on line 9, so we created it as immutable, and it arrived into the fill vec function as an immutable vector. And on line 19, we opted into mutability on it, and then we returned it back on line 25. So you can see for line 21 through 23, we had mutability.
Oh.
Right. But before you added that mute on line 9, that mutability did not persist past the function return, right?
Yes.
I think that's the lesson here.
So I'm curious about this line here, right, where we're doing mute vec equals vec. Like, it's still just one slice in memory, right? There's no copy, there's no cloning. This is just that we take a mutable reference to it.
Yeah, this is all static. Like, the mute goes away at compile time.
Can I do that more than once?
Yeah, you can.
Does that mean there's two mutable references to the same slice?
This one might not work. Yeah, okay. See, that one won't work. But the first, with just one, that's just basically, it's called variable shadowing.
Okay, so because nothing has mutable ownership of the vector, we can just take that here, but then we lose the ability to do that again here. Now, we return.
That teaches us one of the fundamental ownership rules of Rust, is that there can only be one owner. of anything.
There are rules?
Yes.
Okay, so there can only ever
So
be one owner.
there's 3 fundamental rules to ownership in Rust. That everything only has one owner. That owner can give out either one mutable reference to the thing or any number of immutable references to the thing at any given time.
Okay, got it. That makes sense.
Yeah.
So I think I understand. Okay, so I understand this. So this is shadowing. The return drops immutability, but then we can pick it back up here.
Right.
Okay. And is that just something we're supposed to know then? Like when we have a function and we take mutable ownership of something and then we return.
So
Like,
if you think about
can I
this
modify this? Could I tell it returns a mutable reference? No.
Yeah, no, that won't work because one of the things, like the fundamental ideas of Rust that I really appreciate is the code you're looking at is very localized. So if I'm looking at a function, the only thing that I'm looking at in that function is what's going to affect the function. So the signature tells me that it takes in a vector and it returns a vector. But the return type, it doesn't have like mutability or anything because that would change how main was working. And that would make it very confusing to understand for the programmer, right?
Right, got it.
If you do want structures with mutability inside of them without requiring your users to explicitly say mute, you can use techniques such as a cell for that.
Yeah, I again, that's one of those other constructs of Rust I have avoided as much as possible. So, I mean, if we need to delve into that today, then we definitely can. But I don't. We don't need to for this example right now, right?
No.
Phew. Okay. That really helps. I gotta say, like that. I had seen lines like this before. I had just kind of ignored them. I hadn't really understand how they worked, but now I understand that we can have that one owner. It takes it and then releases it. So
if you took this code and you moved it into the main function instead of the fillVec thing, and you did let mute vec equal vec and then did your pushes and then you went let vec equal vec again, you could just temporarily opt into mutability in your main function. This can be really handy when you're doing fairly complicated things where you only want temporary mutability so that later in the function you're not worried about it.
Okay, awesome. Let's move on to Move Semantics 2. Let's get the error message this time and give ourselves a hint. Let's see what we got here. Oh, we actually have a move now. Ah, and there's that thing that I see all the time.
That's
and then that's the one. Oh, my face is covering it, but it says does not implement the copy traits. So yeah, this one I'm very familiar with. So that is on line 10 is the move, and we're trying to use it on 13. So this code looks. Oh yeah, this function is just pretty much the same, right? So.
Yeah, it's almost the same as before, but you can see the print that we're doing is trying to use the vector that we created and then passed into fillVec.
You mean the vec0 here?
Yeah, so we create vec0 on line 8, and then we consume vec0 in line 10, and we give it to the fillVec function. What fillVec returns is possibly a completely different vector. So after
vec0
line
doesn't
10,
exist anymore, right?
Right. Well, after line 10, we have no guarantee that, it's consumed, it's moved. So I think one way we could fix this is make fillVec return or accept a pointer, like a reference. So this is where you do your ampersand, right?
So we mark the type as a reference here.
Yeah.
Do we have to also tell it to pass in a reference?
Right. And now this won't work, right? Because we've got an immutable reference, and we're going to be trying to make it mutable. So this is going to give us problems. So if we try and compile this, you'll see a fun error message.
All right, so we get expected a vec, and we found reference to a vec.
Oh, this is not the error message I was expecting, but it's also one. So fundamentally here, like if we go back to the code, if we're only taking in a reference to a vector, we can't return an owned vector.
So just make it a reference to?
Right, but this is still, we're immutable this whole time. So this is just, it's really not great.
Okay.
Yeah, see, this is giving us the error that you're behind a normal immutable reference.
Okay, so I'm assuming that the approach of passing in a reference to fillvec is potentially the wrong path. I mean, should we?
Well, I guess what we have to consider is what's the intent here? Is the intent to create a new vector and return it, or is the intent to fill up the vector provided? Because I think if we made fillvec take a mutable reference to this collection, then it wouldn't need to return a completely new vector, right? It could just mutate the argument.
Okay, so we want it to be mutable.
Yeah.
So we did this, which means we have to update the signature here.
Correct. And then we could get rid of the return type.
Get rid of it?
Sure. Why not?
Well, this doesn't need this. We don't need to shadow anymore, right? If we have a
we won't need to do that either. Yeah, this is great.
Okay, now would we return this, or would we return a mutable reference again?
Well, I don't think we need to return anything, right? If we're not passing in the vector, we don't need to get it back.
Oh. So that?
Yeah, I think that would work. And then we do have, we forgot about the
the
vec1
assignment,
on line 10, yeah. So we need to change the vec1 calls to vec0. Yeah. But I think that'll work for us. Oh, geez.
Right, so we cannot borrow as mutable on line 15. So what happened here?
Well, we've created vec0 as an immutable, and now we're actually trying to mutate it twice, which is just, it's a no-no. So we're going to have to make the vec0 mutable on line 8. Right? And then we'll have a mutable vec0 to pass a mutable reference into fillvec.
I mean, could I do...
I don't think this will work, but try it. See, fillvec still wants a mutable one.
Right, okay. So we make it mutable from the start. Now, let's see, I don't know. We've got a mutable vector here, right? So
right.
I'm curious, do we still need... Would that not be passing a mutable reference still, or does that make it...
Why don't we try it? Come on. Like, the compiler messages are great. We could find out.
Okay, let's...
I think you will need it there, though.
All right, okay.
Because you need a mutable thing. Yeah.
Okay.
See, it doesn't like us.
So even though it is mutable, when you're working with function signatures, you always have to be pretty explicit then.
Yeah.
Okay. I'm going to break that down. So we had vec0 and vec1, but what we've found is because we're doing a mutation in a function and then a mutation within our function, it's actually probably just best to have a mutable reference anyway, and then pass it.
We discovered that we can't use a value that we've moved out. So you can't use after move. So we had to come up with some way to keep the original value around or be able to use it later. And so we just went for mutability.
Okay. I don't know if this is a feeling that I have, is that right, Rust? But I always feel like I try my best to avoid mutability whenever possible. Is that a goal,
Yeah.
or is that just something I've stuck in my head for no real rhyme or reason? Because this
Well,
isn't
there's
bad code, right?
no. I mean, functional programming tells us you can do a lot of things without mutability, but fundamentally they all end up at IO, right? Which is always mutable. So I don't think mutability is bad, but I don't think you should just blindly opt into mutability on everything.
Yeah.
It should be something you only add when you need it.
I remember reading a book when I was younger. I can't remember what it was called, but it was like The Anatomy of a Computer Program or something. And it was like halfway through the book or 3/4 through the book before they had an assignment, and they made a note of apologizing for having an assignment in the book.
Ah,
And
jeez.
it was a really good book about functional programming and how computer programs work. But the fact that they apologized for the assignment just kind of always resonated with me. Not resonated, but it stuck with me, is what I mean.
I don't know.
Okay.
I'm a big fan of cursed code, so I'm fine with that kind of thing.
All right. Well, again, we're on a second example, and this definitely helps. Um,
Ah, Russell seemed to have a different solution.
ah, so you got a different. Feel free to type it in the chat, Russell. We'll move on to number 3 just now. I wonder, like, if we use the hints, will it tell us how they wanted us to solve it, or does it? Oh yeah, we get some nice text. So it's confirming that our vec0 was moved into the function fillVec when we called it, which means that it gets dropped. Okay, dropped is the word, not disappeared that I said earlier. Or no longer exists. Dropped. Okay, that seems more technical.
So we went for the third option here.
Which is to make it mutable. Yeah, okay. So the other options were make another separate version of the data. So would that have been a clone?
Yeah.
And then option 2 was we could have. Oh, okay, so just do the clone and the subsequent function, and then
Yeah.
okay. So our options were fully mutable or clone the data, which they are 2 different ways to solve the problem, and each have their trade-offs depending on each individual use case.
Rust does a good job making you feel guilty for doing heap allocations.
Yeah, I don't care where I allocate things. I just want
We're
my
not
programs to
allowed
work.
to add new lines to this one.
Oh wait, what? Oh, no lines with multiple semicolons, no new lines. Okay, got it. All right, let me see if I can identify the problem then with this, because I'm over 2 so far. So we have a vector. We create the mutable reference like we did before based on the result of the fillVec. We then this is the same code. No. Okay, so the print vec1 push and then print vec1 again. So the problem here, that looks okay to me. I'm gonna run it. I mean, I know it's not okay, but I'm gonna say, like, I don't think the push function moves anything in memory.
That should be okay.
Oh no! Don't hit him. Don't read it. Oh, it is. So the print is
fair.
taking the ownership of it here.
Yeah.
So my trick is this. That's what I always do first. Thanks, Rust
Nothing
Format.
wrong with
That was great.
Yeah, we added new lines now.
Not my fault. It was Rust Format or Rust Font, depending on how you want to say it. So, I mean, it didn't complain about me passing these in as a reference to.
Yeah.
So I'm not sure why this is telling me.
So this is in fillVec though.
Oh.
Yeah.
Ah, right. Okay. So it's nothing to do with that print statement at all then. Okay. We're passing in. Okay, I got it now. It's not mutable when we pass it in here. We're not doing the shadowing, and we cannot do the shadow because we're not allowed to add any new lines. Got it. Right. Okay. So we need to be able to make. Okay, that's tricky. Damn you, rustlings. I mean, I think, but we tried that with the last one and it didn't really work. So
I think that's a worthwhile thing to pursue this time.
Okay, so what this...
That will imply we have to make vex0 also mute, though.
Would this not just take ownership of it here?
Well, no. So in order to give out a mutable reference, we need to have a mutable ownership.
Right, okay.
Yeah.
So we've not added any new lines.
No, we've only changed them so far.
And I guess this would have to be updated to do this.
Yeah.
Does it say I can delete lines? I mean, that's our solution to the last one, isn't it?
Well, I don't think we should. Hold on. Let's play the game properly, right? Let's try and return the mutable pointer to the vector here.
All right. So.
Yeah, let's do it.
It worked.
Wow.
All right, I'm confused.
Well, because, we talked about how you're allowed to have one mutable reference passed around, right?
Mm-hmm.
So, in 9, we create the mutable vector, and in 11, we get the reference. Then down in 20, we accept the argument also as a mutable reference, and then we return that same reference. So we're not creating any new reference.
Is there any value to this approach over, because I mean, we removed the return previously. Is that the same code or is it different?
Basically the same.
Okay.
This is teaching a slightly different lesson that, you can return a unique mutable reference and still work.
And still get a mutable reference, right? Okay.
Do you need vex0 after line 11?
A question from Russell is, do we need vex0 after line 11?
I do not think we do.
Well, vex0 will be dropped, right? Because vec1 now holds the reference.
Well, no, because it's a mutable reference. Vex0 will still be around.
But doesn't vec1 take ownership of it here? Like,
no,
can I do a print ln?
Yeah.
Vex0?
Yeah.
That's going to work?
I think so. Oh,
no, that's just a formatter. That message I know all too well too.
Immutable borrow, that's fair. So what that's saying, if you look at that, is on fill vec on line 11, we took a mutable borrow, and then we're trying to use that same thing we have a mutable borrow out for before we get back that mutable borrow. So if you look at the code again, because we have vec1 around, it's not going to work. But like, say you moved line 13 down to line 20. And before on line 19, you put a drop vec1. Now that should work because we've explicitly dropped vec1. And so we have the only ownership over 0. Ta-da.
I hate computers.
Yeah.
I just assumed that when we did this, that this was just dropped anyway.
Well, because you're taking a mutable reference to it, main still owns vec0. It's just given out a mutable pointer. And so the big idea here is that if I'm main and I give out a mutable pointer to vec0, and then, I'm done and I'm finished, but I haven't got back that vec0 pointer. Oh. I can't call drop on it yet until I get back that pointer, that reference, right?
Okay.
So it lets the compiler statically track when it will be able to drop a value.
Okay, I'm getting it.
Yeah.
4, I'm gonna get this one now. I feel like I know everything there is to know, which of course is never going to happen. But refactor this code so that instead of having vec0 and creating the vector in main, we create it in fill vec. Okay, so what we have here is vec0 being created. It's read only. And then we get a mutable back. Wait, why is this not got an argument?
Refactor this code so that instead of having vec0, we create it within fillvec and transfer the.
Ah, okay. So basically, this goes away, and we want to be able to get a mutable reference back from fillvec. So does that mean?
I think we want ownership. So if you just stop here, the thing you're doing here is not, like, I know it's not our final code, but this would never work because on line 21 you create this memory buffer on the heap, and then on you return it out of the function as a mutable reference, but fundamentally it won't live long enough.
Oh, I see that message all the time too, and it annoys me.
That wouldn't work, yeah. So in order to do that, you'd have to return the owned value, yeah.
So really what we want is vec equals...
Yeah, like vec new or whatever.
Vec. Well, I guess it would guess a type, but I've typed it now, so...
Yeah.
Oh no, it would be vec. Okay. So then we have... This is not mutable, so I'm assuming we still need this. We push, yes. And then this returns. So does this mean here, because it's dropped from fillvec, that vec1 is now the owner of this?
Yeah, so at the end of the fillvec call, when you return the vector, main becomes the new owner of that variable, yeah.
Okay, so that should work. There we go.
Ta-da.
Okay. I get it. Kinda.
Good.
Alright, we got one more. Number 5.
It took me a long time to start to internalize some of these rules, so don't feel bad.
Oh, this one looks fun. Stars everywhere.
No.
Okay, so make me compile without adding, removing, or changing any lines. What?
Mm-hmm.
Make me compile without changing any code. Is that what it's doing?
Interesting.
Okay, so we have... Okay, let's go through this line by line, because I don't understand this code. So, on line 9, we create a mutable variable called x, which equals an integer. On line 10, we have y, which is a mutable reference to that. And then on line 11, we've got z, which is a mutable reference to a dereferenced y, which would be x. So, I mean, that's not legal, right?
Oh, well, let's try and build this.
Okay.
Yeah, that's fair.
So this is saying that we cannot use star y because it was mutable. But yeah, that's what I thought. Good. Because this is a mutable reference to x, and this is essentially doing the same thing, right? Star y is x. Is that right?
Yeah.
Okay.
Yeah. So how do we fix this if we can't change the code? I don't understand.
Make me compile without adding, removing, or changing. That cannot be right.
So do we have to add stuff like around main?
But it says we can't change any. What? Should we have the hint? I don't understand it.
In main, yeah, maybe.
Okay, carefully reason about the range in which each mutable reference is in vogue. Does it help to update the value of...
Oh gosh, it says you can reorder them, which is definitely changing them.
But that's changing the lines.
I know. Okay, so now with this new knowledge that we can reorder them, let's think about this.
Okay.
So we know that when we have y, we have a mutable, the unique mutable reference to x, right?
Correct. Yes.
And when we have z, we also have a unique mutable reference to x.
Yes.
So I think if we reordered it so that we did not have z existing while we mutated y, it might work.
Like that?
I think so.
That was easy. I knew it.
Yeah. Yeah.
So, no, this only works. I don't know if I'm. Yeah, let me try and articulate this. This only works because we don't use y anymore. Is that right?
That's correct.
Like this will now cause it to fail again. I think.
Mhm. Yeah.
Well, that and my inability to macro. Well, that still works.
Really? Dog.
Oh, but we're not mutating it, right? So
Yeah, that's fair.
there we go. Okay.
Well, that wasn't the right error, but yeah,
Was
same
it not?
idea. No. That was
Oh.
you have to dereference the thing. But doing this would
Oh.
create a new integer.
Oh yeah, this is because these are
Yeah.
fixed size integer. Okay, yeah.
Yeah.
Okay.
These integers implement copy, so
Yeah. And Rust doesn't care about copies. So.
well, copy implies something's very cheap to make a copy of, so
Yep. All right. That really helped my understanding.
good.
So we've got around 15 minutes left. Will we tackle
Jeez,
lifetimes?
really? I don't think we'll get that far, but I'd love to chat about them a bit.
So I want to go through that exercise that you did with me when I was looking for help last
Oh
time.
no. Okay, I don't know if I can remember it, but sure.
Yeah, you have to remember all off the top of your head. Go.
Okay.
No. All right, let me create. I'll just say Rawkode RS. So let's have a function main println. This is about as good as my Rust gets. So
Sure.
cargo run. Really? It's going to compile all of that for hello? Just because I'm in that directory?
Huh. Interesting.
Yeah, that's annoying. I didn't expect. I should have used Rust C. Or, well, I don't know if that would have worked. But I guess it only has to do it once. Oh, does that not work? Well, that doesn't run it. How can I just run a file?
I think that will have created a binary in your directory you can run. Yeah, run the Rawkode.
All right, okay. Can I not just tell it to interpret and run the file?
You're not really supposed to like just ad hoc run Rust files, so.
We're changing those rules today.
Jeez.
Okay. Okay, so yeah, the exercise that you walked me through last time, which has been infinitely beneficial to me, and I think we should share it with people, is that I have ignored lifetimes for as long as I've been writing Rust because I really didn't really want to worry about it.
Yeah.
But the thing that you kind of helped me realize is that even if the lifetimes aren't in my code, they are still here. They still exist, and we can make them explicit, and just that process really helped me understand it. So I'm not sure if we need to type new code or if we probably will, right? Won't we? So should we have a new function that just prints out?
Gosh, here let's do let's make a string. Rawkode. Make a string here, and we can print out that string, right? And then, like, this is basically what we were doing before. Do thing.
Yeah, and my awkward understanding of string and string and string and string, which is now much better now because of this.
Yeah. So, wrong. I don't really know what I'm doing here, but we're gonna do it. Yeah, so this will give me the fundamental. We were talking about string and str, right?
Yeah, that was right. Yeah.
Yeah. So if you have a string, which would be this, in here, you have ownership of a memory buffer of like unsigned 8-bit integers. Now, if I was to do like as str here, so that I got in some str type, which I'm sure a lot of people are used to seeing in Rust, that is unowned. It's just a reference to one of those same memory buffers.
Okay.
So you can think of a reference to a string as an str with a lifetime shorter than the string. So when we talk about lifetimes, if I made some string processing function like split that took in one of these string strs, which is one of these unowned slices. So I didn't own the memory. It would essentially be doing this where I have this lifetime, which is just a generic type. You know, if you've written a lot of Rust, you might be used to seeing generics like this. Lifetimes are just another type, basically. What that's saying is just that the xstr has the same lifetime as the function's call. So you can think of A starting here and then ending here. So when I pass in the str up here, that reference will only be alive until line 13.
Okay.
Because I'm not assigning it here. So if I had like let ref of thing equal this, and I did return that same str, it would persist all the way through to here.
Right. Okay.
Yeah. So there's a big difference between an unowned type and an unowned type, right? And references, as we saw in Rustlings, kind of allow us to work with them. But when you get into scenarios where you have references of references, lifetimes are really powerful because, you know, in this case, this is obvious. You know, if you give me a string and I return to you one of these, sorry, if you give to me an str and I return to you an str, they pretty much have to be of the same lifetime. Because if you give me unowned memory and I give you a pointer to unowned memory that's within that unknown memory, I can't do anything other than promise that it will be valid for as long as the unknown memory is valid. But let's say we were writing a split, so we were actually splitting up this unknown slice. We might have some, you know, set of subsets of this str. So we might return a vec of str instead.
Right.
It still all have the same lifetime, so it doesn't really matter. but I've probably written very broken code here, so I would hesitate anyone trying to run it. But
The thing
lifetimes.
sorry, Nico.
Go ahead.
I was gonna say one of the weird situations I always seem to get myself into, and I've never really understood it, is when like I write a function, and it tells me that the value doesn't live long enough to be returned.
So usually that's because you're doing something like you're trying to return a reference to, like, say I did let a equal, and then I return a. This would actually be quite valid because the let a equals thing there is a static string that gets actually written into the binary. So if I was to run strings,
does that mean that is this?
Yeah, that's that.
Right. Okay.
So the static means it's going to be alive for the whole time. So like this is completely valid. That I could make it like that. This is a valid function and it's fine.
Okay.
But the moment I try and do let's say I do this, and I do ref of a like that, and then I try and return ref of a, because I'm trying to return a reference to some memory that is only alive during the function call, this owned buffer. That value is not going to be around at the end after the end of the function call. So in main, when I called this up here, like this,
yep.
X in this case would be an invalid pointer, right?
Okay, so can we make this explicit? I want to see if I understand this correctly.
Yeah.
Is that we're saying all functions already have a lifetime. Where does that go? Is it here? So this is like an A?
Yeah, so like you could think of all functions having a lifetime. And
which means that this here is lifetime of A. I don't even know what I'm... Like this reference, would that have the same lifetime?
You could think of this, say where you're doing something really complicated with string processing, you might actually see something like this.
No, I don't like it.
Yeah, so this is about sub-lifetimes. And what this is saying is essentially like all of the lifetimes B are shorter than or like within the realm of A. And okay. Yeah, you don't like that, but that's fundamentally what's happening. It's like this is some random lifetime called who knows what. That's a sub-lifetime of A.
Right, okay.
Yeah.
I think I need to do some reading on lifetimes, and I'm based actually now just on where this is going. I feel like this lifetimes are probably an entire episode on their own. With like I didn't even know sub lifetimes were a thing. Sub lifetimes.
Yeah. Well, we could also talk about ARC and RC and how boxes work. There's lots of fun to be had.
So boxes are just something that I've only just started using since I've been working on Comtria, just because I have so many different like subtypes on enums, and I kind of needed them to pass those around. So I've been dragged into learning that, but they're slowly starting to make sense. And I understand it. It's like we have this thing of unfixed size, and a box is a way to pass around like I think it's just a pointer to it. Is that right?
Yeah. So turning something into a box puts it on the heap. And then, so if you do like a boxed-in trait, that just basically is putting a pointer to the v table on the heap.
Okay. I think what we'll do, just given the time and how much more stuff we could potentially go into, is I will just chat with you later, and we'll maybe see if you're up for doing another episode where we look at all those other cool things that I have no idea about. But that was really helpful for me, like just going through those Move Semantic things and having your experience help guide us, and just even explaining it all really helps, and I hope that other people got value from that as well. So
Yeah, I had a lot of fun. Next time you'll have to let me make some good examples too.
no, that's not allowed on this show. No, no. All examples must be terrible, terrible, terrible. Although your examples were definitely perfectly fine. I brought the terrible. Thank you
I don't know,
for.
I wrote some pretty trash code there.
Yeah, I think when it's in the name of explaining concepts, that is perfectly valid. Perfectly valid code. We got a thank you from Navina as well. I will reiterate that. Thank you so much for taking time out of your day and walking me through this. Like I said, it was really, really, really helpful. And I'm looking
Thanks for
forward.
having me.
And I'm looking forward to hopefully having another episode. And your dog is looking mighty cute in the background, flying out
Yeah.
the door.
Well,
All right.
feel free to connect with me on Twitter or whatever, and happy to say hi to all your folks.
Awesome.
Thanks so much.
All right. Have a great day, and I will speak to you again soon. Thank you.
Bye.